A data center can drink 5 million gallons. Not a bathtub. One building full of computers. So why does your cloud need a water bill? Because AI has a body. You send a prompt. Somewhere, chips wake up, electricity arrives, and heat starts piling on. Most of us picture AI as weightless, little magic words in a chat box. That picture is incomplete. The chat box has industrial plumbing backstage. And the thirstiest part is not the computer itself. It's the heat leaving the computer. That's the culprit. Heat. The invisible squatter that demands rent in water and electricity. We're going to trace that water, including the awkward question nobody puts on the brochure. When a town is rationing water, why does a server campus still get to sip? Hold that thought. Start inside the building. Servers turn electricity into calculations, and nearly all of that energy ends up as heat. Even useful computing is basically an extremely expensive space heater with homework. Older facilities often use room air, giant fans, chillers, and sometimes water-cooled coils. Air cooling works, but modern AI chips can pack a ridiculous amount of heat into a small area. Picture cooling a pizza oven with a birthday candle. The fan is trying. Bless it. Water carries heat far better than air, so pipes can pull heat close to the chips. This can be direct-to-chip cooling. Think tiny plumbing hugging the hottest parts. Sounds like the fix, right? Not quite. The heat still has to go somewhere. That little detail is why closed loop doesn't automatically mean no water. The loop can recycle its coolant. Rejecting heat is the part that gets thirsty. Meet the usual exit door for heat, the cooling tower. Warm water spreads across fill material while air rushes through. A small fraction evaporates. Evaporation steals heat. Same trick as sweat cooling your skin. Except your sweaty forehead isn't usually attached to thousands of high-powered GPUs. Now the confusing vocabulary. Water withdrawal means taken from a source. Consumption means not quickly returned there. Those are not the same number. And mixing them up makes every headline sound like an argument. Some water may be treated and discharged. Tower water mostly leaves as vapor, plus smaller purge streams. So when water becomes vapor, it hasn't vanished from Earth. It has vanished from that local supply for now. That isn't a magic trick. It's a local timing problem. And timing gets brutal during heat waves, when servers need more cooling and communities need more water too. One regional study or one company total can't tell you what happens at a stressed neighborhood watershed. Location changes everything. A gallon near abundant rain is not the same as a gallon during drought. That's why residents get angry when lawns face restrictions and an industrial campus has a special contract. Are they simply allowed to do that? Usually it comes down to permits, contracts, local law, and what utilities approve. That may be legal. Legal is not the same as painless for a town with a shrinking reservoir. There are smarter options. Use reclaimed wastewater, capture rain, or switch cooling modes when conditions allow. Reclaimed water can spare drinking quality supplies, but it needs pipes, treatment, and enough reliable volume. You can't just point at a sewage plant and yell, "Problem solved." Pipes are expensive spaghetti. Dry cooling uses air instead of evaporation. Great for water. Less great when the outside air is blazing. Hot air gives cooling equipment less room to work. Like trying to chill soup with another bowl of soup. What about putting every data center somewhere cold? Helpful, yes. A universal escape hatch? No. They also need power lines, fiber connections, land, permits, workers, and customers close enough to avoid delay. The ocean sounds limitless too, but seawater corrodes equipment and warm, salty discharge still affects ecosystems. The sea isn't a giant free radiator. Nature also gets a say. And AI isn't alone in this building. Streaming video, cloud storage, searches, games, and crypto can use the same physical infrastructure. So no, every gallon isn't AI water, but new AI demand can push a crowded system harder. It's the difference between one extra guest and a surprise busload arriving at dinner. There's a second water footprint hiding before the servers ever turn on, making the chips. Semiconductor fabs use enormous amounts of ultra-pure water to rinse wafers during manufacturing. A fab can use millions of gallons a day. Tiny chips, giant shower bill. Is chip making bigger than running AI? It depends on the chip, its lifetime, the cooling design, and the local power grid. There isn't one honest universal number. Anyone selling one is skipping the map. Electricity adds another hidden layer. Depending on the grid, generating power can use water too. That means a chatbot reply can have water upstream, on-site, and back in the factory. 3 different shadows. Now for the thing brochures rarely say out loud. Efficiency doesn't answer the local water question. A facility can improve its water efficiency and still strain a watershed if it grows fast in a dry place. That's why company-wide water-positive goals need local details: where, when, what source, and who shares it. Replenishing water elsewhere can help. It doesn't automatically refill the exact creek under pressure today. And what about all that waste heat? In the right place, it can warm homes, pools, or businesses. But heat networks need nearby buildings, costly pipes, and demand when the heat is available. Heat is fussy. Still, dumping useful warmth into the sky while burning fuel for nearby heat is a pretty weird arrangement. So can AI ever be justified? That isn't answered by pretending its physical costs don't exist. It's answered by asking what the computing does, what it displaces, and who bears the cost. A tool that saves energy somewhere may still create a water burden somewhere else. Both can be true. That's not anti-tech. It's anti-invisibility. The final answer is almost annoyingly physical. AI needs water because it makes heat, and heat must move. The real fight is over where that water comes from, whether it evaporates, and who needs it at the same moment. So the next time an AI answer appears in 2 seconds, picture the whole body behind it. Not magic. Metal, water, power, heat, and a very real place on a map. Would you want full local water data before a data center opens near you? Tell us below. Subscribe for more.